Could you share what inspired you, what motivated you to work on this?
I think we were having dinner at a Filipino restaurant when we thought of this paper,
Yes.
if I remember correctly. Is that right, Igor?
That's right. It's all due to the digestion issues. No, I think we were Sam and I would try to find best ways for us to bridge our interests. My interests in wisdom, and to some extent in AI, and I think Sam also has interest in AI and broad cognitive science. And we tried to find what's in common because Sam has done this wonderful research on conceptual work on the notion of radical uncertainty and sort of intractable problems. And that's very much sort of the realm within which wisdom operates. And then we started talking about it. And one natural question was, well, what about all those intractable problems and radical uncertainty for AI? And what would it look like if we were to build that in? What kind of wisdom would we need? And so that one thing led to another. And that's how we started with this. Thank you so much, Sophia, for inviting us to join this group. And hello, everybody, from both Sam and myself. We'll try to do it in tandem. This is our first time. Hopefully, it will go well. We'll try to save the questions until the end, but I promise we will not take too long. If there is something that's unclear, hope we can clarify it at the end. This is a project that is very much a collaboration, not just a collaboration for Sam and myself, but for a very illustrious group of other scientists, several names you will undoubtedly recognize. The preprint for this position paper is on arXiv, has been since November. We're currently revising it a little bit to flesh out some engineering components at the end. But if you want to know more, and if you want to praise some things about this work that we'll present, please direct it also to others. All the critique, we'll try to take it here. What is the key point? If there are any key points, if you miss anything about this presentation, and if you decide to fall asleep, maybe the next 2 points will be the most critical one. Our position is the following one. We assume that today's AI can perform many tasks and does that quite well. With every day, with every month, we see some new benchmarks being beaten that we thought AI would not be able to do as well as humans. It's an ongoing progress. At the same time, we also know that there's quite a number of limitations, and especially limitations concerning complex, ambiguous situations that may not be part of the training set. We argue in this presentation that one way, there are many ways, but one way to approach this and to address the struggles of the modern AI systems is to bring in some wisdom into it. And that's an amorphous term that can mean many things, and we'll explain that in a second. But essentially, what we need is an ability to reflect on one's own thinking, which is the classic definition of metacognition, and to do so in a context-sensitive way, in an epistemically humble way. So those are the key points. If you want to check out after this and come back to the discussion, we can do that. But let us unpack this. What are the current shortcomings of AI systems, many of which you undoubtedly know? We know that AI systems excel at tasks, at very specific tasks, many of which are astounding. But we also know that if a particular task is presented in a novel environment, or the environment is generally unpredictable, sometimes the systems struggle. And the issues that are generally involved, and there are 4 different domains that Sam and I would like to address today, are the domains of robustness, explainability, worries about cooperation, especially for people who are coming from existential risk due to AI, and issues with safeties, with AI reasoning being opaque and hindering explainability, worries that AI will struggle to cooperate with other humans and other AIs, or risks when AI blindly follows fixed goals without considering circumstances, without considering context and possible conflicts between different goals. One possible cause that we would like to bring to the table today is the lack of wisdom. Now, what is wisdom? And here we need to take a little detour. Maybe one way to develop an intuition about the human wisdom is to consider the following three examples. So I'll just read this to you. There's more in the paper, but hopefully it will give you a bit of a sense how in humans we typically think about wisdom. Here's one example about Willa. Willa's children are bitterly arguing about money. Willa draws on her life experience to show them why they should instead compromise in the short term and prioritize their siblings' relationship in the long term. In this example, we have considerations of long-term perspective versus short-term gains. There are different goals, different viewpoints. What may not benefit you in the short term may benefit you in the long term. That's just one example. Here's another example. Daphne is a world-class cardiologist. Even though she's a world-class cardiologist, she consults with a much more junior colleague when she recognizes that the colleague knows more about the patient's history than she does. In essence, Daphne recognizes limits of her knowledge that as applied to this particular situation, despite the fact that she's arguably a much more knowledgeable cardiologist than her junior colleague in general. Here's a third example. Ron. Ron is a political consultant who formulates possible scenarios to ensure his candidate will win. To help generate scenarios, he does not only imagine the best case scenarios, but also imagines what would happen if his client would lose the election and considers possible reasons that might have contributed to the loss. So thinks about so-called pre-mortem, engages in so-called pre-mortem exercise. What would happen if the desired outcome were not to occur and in fact the undesired outcome were to occur? What could be the contingencies there? What could be the scenarios? Now, these are very different examples, but in each of them, we would probably think that what Daphne, Ron, and the first person did were some elements of wisdom. They were showing some elements of wisdom in their responses. What is wisdom? What is encompassed in here? Well, perspectives on this vary. Here's just a set of theories that currently circulating in cognitive and social sciences. Some of them are indeed about considering long-term perspectives, balancing different viewpoints and perspectives, balancing different interests. Some of them are about emotions. Others are about being sort of intuitive versus reflective. Some of them about managing uncertainty and regulating yourself. Some of them are about being flexible. There's a lot of different viewpoints. And if you open an encyclopedia entry on wisdom in philosophy, you will also see a whole range of viewpoints. That is, of course, not very productive, especially if you want to build in some kind of a wise AI. So very recently, there was an attempt to bring those different perspectives together and figure out, is there something in common if we try to look at these different classifications of wisdom in human behavioral sciences? What happened was that indeed, after classifying and codifying responses across different working groups from different parts of the world who work on this topic, a whole range of perspectives and different categories emerged. What was very surprising that at the very top, in almost all definitions, we have some features that are quite resonant with those three examples that were presented earlier. Namely, they involve perspective taking. They involve consideration of different contexts and how this context may vary. They involve this sense of epistemic humility, like in Daphne's example, who recognized limits of her knowledge in a particular case and asked somebody else for advice. It involves balancing of different interests and considering that there is often a trade-off in complex situations that we as humans encounter in our everyday life. Those are the features that are often characterized as central to wisdom. So, and these features are metacognitive. And I would like to pass now on to Sam, who will tell us a little bit more about why metacognition is central for wisdom, as well as how it can benefit building wise AI.
Thanks, Igor. You can go on to the next slide if you wouldn't mind. In thinking about this and looking at this wide array of different theories, this kind of set of different characteristics that people have identified, Igor and I have been trying to bring this literature into dialogue with what we know about the rest of how the mind works with cognitive science. We think there are two important generalizations about wisdom. So one relates to what it's for, its function, and the other relates to its mechanism, how it works. First, to talk a little bit about the function, we think that basically wise reasoning is necessary for navigating intractable problems. Problems of the sort that you wouldn't find in a textbook because they resist analytic techniques. There are a lot of different types of intractable problems, and it can be kind of a line drawing exercise deciding exactly which characteristics characterize any given example. But roughly speaking, these 7 types of things we think characterize most of the different ways the problem can be intractable. So it could be incommensurable. You're trying to compare 2 different values that are ambiguous or really difficult to put on the same scale. So for instance, if you're trying to decide whether to pursue a career as a clarinetist versus a lawyer, it's not clear that to a given person, one of those is clearly better than the other, but they're also clearly not the same as each other. So it would be wrong to say that a person is maybe indifferent between those 2 careers. They're not different, they're just incommensurable. A second reason that a problem could be intractable is because it is transformative. The person before making a decision might be a different person in some sense from the person afterwards. So when you're choosing whether or not to have a child, for example, many people report that this really changes the way that they think about the world and the types of life priorities that they have. So when you're trying to maximize utility, are you trying to maximize the utility of the person before the transformation or the person after the transformation? Third reason is that a context might be radically uncertain. So we can't list all of the different potential outcomes or rationally assign probabilities to those outcomes. So if you're trying to predict a disruptive social change in the future, I would wish you luck in using an optimization technique for doing that. Problem might be chaotic, where there's a strong nonlinearity or a dependency on the initial conditions, like when you're trying to predict the spread of a contagious disease, as we all learned quite a bit about a few years back. Problem could be intractable because the data generating process is non-stationary, meaning it's changing unpredictably. So you might argue that if you're trying to predict the prices of things or the interest rates in the distant future, we don't have a detailed enough model about how the economy works, and the underlying processes might be changing over that period of time. Another reason is that a situation might go beyond our personal experience or data. It might be out of distribution. This quote from the economists Kay and King I like on this type of issue related to predicting radical technological changes was that if you're trying to imagine before the wheel was invented, what's the probability of inventing the wheel? It doesn't even make sense to ask what that probability is. By identifying a probability of the wheel, you've just invented the wheel. Or finally, and maybe more familiar to us, a problem might be computationally explosive. So doing optimization might be possible, but it would be prohibitively resource intensive. And this is true arguably of many decisions that we face outside of a textbook. So you can go on to the next slide, Igor. So second generalization has to do with how we try to manage these problems. It might not be right to say that we're solving the problems, but we are constantly facing these types of problems as human beings, and we have to have strategies for managing them. And we argue that wisdom basically comprises 2 different types of strategies, which go hand in hand, and you can't really have one without the other. The first are what we call task-level strategies, which are also sometimes called object-level strategies. And those are strategies that we apply to a particular problem. They take some sort of input, we use that strategy, and it recommends some sort of action. So there are different types of task-level strategies that have been studied in cognitive psychology. 2 of them are heuristics and narratives. Heuristics you're probably familiar with. You simplify a problem by focusing on just one or a small number of relevant cues. When Wilma, actually I think she was called Willa earlier, when Willa was giving her children advice earlier on in this talk, she had some rules of thumb that she was using when advising her children. Those are examples of heuristics. Another is a narrative. As humans, we have a rich causal understanding of the world. We have a rich database of other similar problems that we can draw on in the past. So we use those different sources of information to generate some sort of mental model or narrative of a problem space, and we kind of run that narrative forward to imagine what would happen in the future. And that's what Ron was doing when he was planning out these different scenarios. And we think for the most part, these task level strategies, heuristics, and narratives, and potentially others, are mainly the product of cultural evolution. So if you think about whose advice we listen to, tends to be people who seem to have developed different task level strategies that often have served them well in the past. Or if you think about which kind of advice has survived across generations, it's often little proverbs or bits of wisdom that have been handed down across generations. So you can go on the next slide, Igor. Task level strategies are critical, but they're not sufficient. And the reason is because they simply don't in themselves give us the answer for three reasons. One reason is that those task level strategies themselves require inputs. Doing a narrative, this narrative strategy that Ron is using to generate potential actions for his candidate, he needs to know all sorts of things about how the world works. He has to draw on relevant analogies. Those strategies require inputs. So we need some sort of system for getting the right information to hook up with those strategies. The second reason is that the strategies can conflict with one another. Daphne might follow the wisdom, I'm an expert, I'm going to trust my judgment. Or she might follow the wisdom, I don't know, there's a more knowledgeable expert than I am. So how are we going to navigate conflict between those two different strategies? And then the third reason is that a strategy might work kind of in general, but can produce a nonsensical outcome in some particular case. So if Willa knew that one of her children actually really was trying to rip off the other child, she probably wouldn't just advise them to compromise in that particular case. You have to have some sort of sanity checking procedure. In order to accomplish these three different goals, basically what we're developing here is this idea that you have to manage not just the task that you're trying to solve, we actually have to also manage the strategies that you're using to solve the task. And the way that we do that is through these different types of metacognitive strategies of the sort that Igor mentioned earlier on in the talk. So things like intellectual humility, where we're aware of our uncertainty and the fact that we might be wrong. Epistemic deference, we listen to other people in appropriate situations. Scenario flexibility, we imagine how a scenario could unfold in different types of ways and identify what are the potential pain points or contingencies along that scenario. Context adaptability, where we're not just kind of blindly drawing on analogies to previous experience, but critically evaluating how the situation we're in is and isn't comparable to those other situations. Perspective seeking, where we are drawing on a diverse range of expertise and perspectives from other people, and viewpoint balancing, where we're trying to integrate discrepant interests. As Igor mentioned before, we think a fundamental problem with current AI systems is that they lack robust metacognition. And we think this is important because it would allow these systems to know what they don't know, switch strategies when the context requires it, and to seek and integrate these external perspectives. We're cognitive scientists, not machine learning experts. So from our perspective, I think the key thing here is identifying what are some of the specific challenges that AI faces. To what extent do some of those challenges have analogs for humans? Is it the case that wisdom, in fact, is helpful for solving those strategies in humans? And to the extent that is, that's kind of a proof of concept that having some wise strategies, both object level or task level, and metacognitive strategies can help to circumvent those problems in humans. It's not to say that necessarily wisdom would look exactly the same in an AI system. It probably wouldn't, but at least we would know that in humans, this is one way forward. Igor mentioned before these four different challenges that we think kind of carve up pretty well the space of different shortcomings of current AI. So the first one is robustness, which is whether we can adapt to new and unpredictable challenges. An AI system, or for that matter, a human being, could fail to be robust in at least three different ways. They could be unreliable. You give them similar input and they just give you really different outputs each time. They could be biased, which of course is what we talk about the most probably, making systematic mistakes that are in a consistent direction. Or it could be inflexible, where we kind of rigidly apply a strategy in a situation where it maybe doesn't apply. So it causes us to perform poorly in the face of novelty. As a cognitive scientist, we grapple with how humans are able to solve these types of problems. And in particular, this last problem of inflexibility is really important in humans because we're constantly facing novel environments. And we actually do pretty well in the face of all of that variability and novelty. In humans, there are a few different ways that wisdom contributes to robustness. Heuristics, arguably, by relying on fewer pieces of information, can help us to avoid overfitting. So just like fitting the noise rather than the underlying signal, they arguably generalize better to novel situations. Intellectual humility, we face a novel situation, but we moderate our confidence downward. We don't just assume that if we're applying this strategy, it's going to work just as well as in another case. And then sanity checks, ensuring that our outputs are sensible, so that we're not, so in a new environment, even if we apply this previously useful strategy, we check whether it in fact works reasonably well in this situation. Second benefit relates to explainability. Key problem for AI here is that the rationale for an AI system's outputs can be opaque to the users, which is a problem for working effectively with them, trusting them, and figuring out what went wrong when you get some sort of weird output that you weren't expecting. If it can't explain why it got that output, you're not able to easily troubleshoot the situation. So of course, humans are reasonably explainable. We are often called upon to justify our decisions to both others and to ourselves. And how exactly this works is a little bit controversial within cognitive science. So there's kind of like an older classical view, which says that we have some ability to introspect our thought processes. And the way the metacognition works is that we are consciously thinking about monitoring those thought processes and we're observing them. On this view, we can simply report those observations. A different view is that our thought processes are highly opaque. So we're not observing our thought processes. We're actually just inferring them or even inventing stories about those thought processes. We monitor the outputs of those processes, and then we turn those into some sort of story. Still, we nonetheless need metacognition in that case to explain, defend, guide, and modify our behavior. So either way, metacognition plays an important role for explainability in humans. The problem of cooperation is that AIs are increasingly asked to work as part of bigger networks. So you can see this in both AI-AI cooperation, such as autonomous vehicles trying to negotiate traffic, AI-human collaborations like surgical robots, or the role of AI in moderating human-human cooperation like social media content curation. Cooperation is a highly studied problem in humans. We know fair bit about what makes humans able to be so cooperative relative to the rest of the animal kingdom. And at least 4 of the factors are listed here. So we are quite good at understanding complex social situations because we use theory of mind or perspective taking to infer what other people are thinking. We are effective at communicating, and an important part of communication is being able to know when you can trust what other people are saying. So we filter information from others, and we have developed so-called epistemic vigilance cues that we use to evaluate whether the things that other people are telling us are plausible or sensible. And then we use those in turn to update our confidence in what other potential informants are saying. Humans use cues like reputation to align our incentives with one another. So if I do something that harms another person in my social environment, that can in turn harm my reputation, which gives me a cost. So it brings my incentives into alignment with others in my community. And then, of course, humans in historical time have developed social institutions that allow cooperation on a much wider scale than our biologically evolved mechanisms do. And then the final benefit that we talk about in this paper is for safety, which in this context means avoiding harmful actions and unintended consequences. So this has 2, I think, fairly different faces. So one of them relates to what's often called alignment, which Igor is going to touch on a little bit more in a moment, which is the observation it just might be very difficult to curtail an AI that aggressively pursued goals that are different from our own. And it's difficult maybe to articulate what all of those goals are supposed to be. And then the second is a much more prosaic kind of safety feeling, which is just if a system that we come to rely on performs badly, that itself is a risk. So if we're getting bad tax advice from an accounting system or biased parole decisions, for example. Here too, in humans, wisdom has an important role. So we share a set of common sense assumptions with other people in our environment. So it's not so difficult for us to align ourselves in at least some situations with others in our immediate environment because we have that kind of common set of unspoken assumptions that we can rely on. And finally, we think that metacognition in a further sense is quite important for avoiding the second kind of failing, which is that we can anticipate the potential risks or the potential failure modes and try to correct for those in advance and see where to devote cognitive resources. And then the final point here is that for a system to be safe, it's useful for it to be robust to new situations, explainable, people being able to understand why it's failing in a particular case, and of course being cooperative in the sense of having its incentives aligned with others. And now I'll hand it back over to Igor.
After reviewing this 4 different domains, there's this one big elephant in the room, and this elephant has to do with alignment, something that a lot of you probably heard about. How do we align the systems with the humans or with human interests? And our take on this is why? What are we even aligning with? Whose values are we aligning with? We know from cultural research done by many colleagues of myself and also my own that there are huge differences in values and beliefs around the world. So which value system are we actually taking to align the AI system with? And then at what moment are we aligning those values, given that values evolve? They constantly change. Where what we value now is not the same what the same country arguably valued 100 years ago. That's why potentially one of the way around this for us is to think about focus on metacognition, wise reasoning. By focusing on this metacognitive checks, by considering the integration of different perspectives, by considering intellectual humility, we can adapt to different changing social norms and avoid the gold traps that we may otherwise stuck with if we align too much with one particular set of characteristics. This then, of course, elegantly circumvents the whole idea of alignment. And we can talk more about whether this is a goal or not. But for us, the point here is that it may be of benefit not to consider the notion of alignment itself, but consider this metacognitive component that may in fact then yield better and more accurate alignment in turn. There are a lot of challenges to what we're proposing here. If you want to build some wise AI systems, whatever that means, and in our case, it means relying on these different features of metacognition, there are some technical challenges of, for instance, how to balance diverse viewpoints. There are some conceptual challenges. For instance, how do we even define what wisdom benchmarks would be? There are concerns with memorization. There are concerns with the process. There are several concerns with the context, because wise strategies are by default context sensitive. And so the information provided to the AI for benchmarking must then contain sufficient details to match the rich context the AI would have in the real situation. There are also social challenges. How do we align systems with these ever-evolving values, as we already mentioned before? So here are a few suggestions. And again, like as Sam, I also want to point out that we're coming more from the psychology branch of cognitive science. So we rely on those of you in the audience who are coming from engineering and computer science to help us figure out if some of these conceptual suggestions are reasonable or not. For instance, one idea could be to build in explicit metacognitive checkpoints and error detection loops. So if, for instance, we would introduce a specific computational modules, define decision points, for instance, certain layers in transformer architecture that would then assess the outputs, the output uncertainty and coherence. And that can be achieved in different ways. For instance, we can pause execution at certain confidence thresholds to reassess decisions, whether this kind of model confidence falls below calibrated uncertainty threshold. And then that would lead to regeneration or potentially external verification. So explicit metacognitive checkpoints is one idea. Another idea would be to have some form of epistemic source tagging and reliability updating. I'm not sure how reasonable this idea is, given the opaqueness of the current training data in the first place. Let's consider we having some kind of well-curated open source data that we have added some structured meta tags that explicitly encode epistemic reliability. By pre-computing and embedding this metadata, we could possibly add this reliability indicator information into the systems, along with raw tokens or data points. A few more suggestions. hierarchical or reflective reasoning architectures. So here we would be sort of inspired by typical cognitive models, where we would have a metacognitive layer explicitly monitoring or selecting task level strategies, as Sam pointed out earlier. So we would have then this layer that would help us figure out which of the narratives, which of the heuristics potentially to rely on, which of the tasks, strategies to use for a given situation. This can be done through an explicit reflective subsystem designed to audit internal consistency and logical coherence of essentially sanity checks. Two more: transparency via metacognitive narration. For instance, a design system that would be capable of transparently narrating their internal metacognitive reasoning, thinking aloud protocols to users, adding explainability and making reasoning easier to debug, for instance. This can be done through this type of think aloud protocols. And to some extent, this is already partially implemented. Of course, the question is whether the explanations provided by AI systems right now are post hoc. And that's sort of similar to this discussion that Sam alluded to earlier between the classic view and the more modern view, whether we humans actually know and can explain our reasoning and our decisions. There are different perspectives on that. Our idea here is that we can use this potentially for interactive debugging and for building, for instance, auditing interfaces. To wrap this up, so there's different possible strategies. What we are talking about here is a possibility to consider not just optimizing current AI systems for intelligence, making them smarter, but making them wiser. And by wiser, we are actually aiming to figure out how to build in metacognition for the purpose of the robust, explainable, cooperative, and potentially safer AI system. And in that sense, if we are able to achieve that, the hope is that the machines can then adapt to the context, learn from feedback, and promote collective well-being, both for humans and for human-machine collective systems.